second. All right. So again, Craig Smith. This talk is going to be on automotive exploitation techniques. We're not going to go into all the little details of some of the CAN bus network type things. There's plenty of places to go look that stuff up. You can, like we mentioned before, there's the CAN Hacker's Handbook. That's a free book. You can go get it. It'll give you all those kinds of details. But we will go through the process of how you go about assessing a car, how do you do exploitations on a car, what are your goals, and then I'm going to talk about two new tools that are maybe overkill, but it'll be fun. So let's see if I can get this guy flipping over. Or not. Let me unplug him and plug him back in. There we go. All right, so it seems to be working now. So when you decide you want to attack a car, all cars are pretty much different. So it depends on your year, depends what features you have present, depends if there's any modifications to it, what package you got, your trim, all that good stuff. So if you're working on your car or if you're working on an engagement, I do a lot of engagement for automotive companies, you're going to be given a certain car. And so you're basically going to have to figure out, okay, well, what does this car have? What kind of areas am I going to have to attack? That's your attack surface. You want to figure out what your goals are, what threats and risks are there, and then determine the payload. What are you going to do once you get on a car? Hacking cars isn't really that hard. It's pretty simple. There's a couple unique pieces that make up a car. I would say they're probably harder to defend than they are to attack. This guy, there we go. Oh, that's a fun way of doing that slide. Fix that. Let's do it this way. We will do this live. I'm having mouse issues on top of everything. Okay. So when you're thinking about the attack surface, it's more than just normal application stuff. So if you've ever done any kind of application threat modeling, anything like that, you're typically looking for inputs. So these inputs are things like your form fields. There are maybe if it reads a log file or parses some kind of data. Those are all inputs to your application. You basically just treat a car as an application. So your inputs become way more varied. You can get inputs from other vehicles. You can get inputs from your sensors. You get them from your key fobs. You get them from if it has wireless or Bluetooth capabilities. You have physical inputs as well. So you have CD-ROMs. You may have USB connectors. You have the connector underneath your car called an OBD dongle. Those just plug underneath your steering column. You see them if you get an e-check. They'll use it for that. And depending on who your client is, the physical aspect may matter a lot. For instance, if your client is somebody who maybe they sell taxi cars or police squad cars, where the wires run in the back seat become very, very important. Somebody can get to these network wires from the back seat. You can do a whole lot of damage to a vehicle. So don't think just because it's physical, it doesn't matter. It does matter. If you're just starting out, then you want to probably start with the physical before you move to wireless. And you can identify them all. They're going to be different on each vehicle. Nowadays, the components have become a lot more common. What that means is that it used to be these were like one-offs. So each vehicle would have their own kind of thing that was kind of custom built for that vehicle. When I first started getting into this in 2008, I started with an infotainment center. They're also known as IVIs. But my IVI was a little nav unit, and the processor on it was a Hitachi SH4 processor. I mean, it was running Windows CE, which is very identifiable. But the processor, I didn't really know. After a little bit of Googling, turns out that was the same processor used in a Dreamcast, which is really cool, but I didn't know how to write assembly for Dreamcast. But that doesn't take long to kind of get past. But nowadays, you don't need to do that. The new systems are, a lot of times, they're Intel, they're ARM, they're things you're pretty comfortable with. They're running Linux, they're running, it's still Windows CE. There'll be a QNX or a Green River makes one too. But once you're on one of these IVI systems, the ability to find an exploit isn't super challenging. It's actually the same kind of stuff you would do on a normal desktop. even your code now is x86. So you can even test your code and what your exploit's going to be on your desktop before you use it on one of these nav systems. So the only real barrier to entry to getting a lot of these attacks is just figuring out how to get to the OS. Charlie talked about yesterday, Charlie and Chris talked about building your own test bench. If you get a infotainment center, you can get one. I recommend one from Tizen. Tizen's nice because it's well, it's not open source hardware, I don't think, but it's open source software. It's what a lot of people are using to develop their infotainment centers. They still cost about $1,000 because they're new. But you can kind of pick them out directly for whatever pieces you want, how many CAN buses you want, what kind of features you want. You just buy it. They give you the full dev studio because it's the same one that the auto people are using to dev on a lot of times. So it's a good one to kind of get your bearing on and test without really breaking anything. I recommend Tizen's. And then once you're on, which is typically, like I said, once you're on the OS, you see, oh, well, it has an access point, that provides its own Wi-Fi, which is running like host APD. A lot of times it's simply just a matter of looking at the version number and comparing them to CVEs. These things rarely get updated, so you'll be kind of disappointed if you thought this was going to be a hard challenge. It's not. It's simply just a matter of figuring out what versions and then saying, okay, this is vulnerable. There's a known vulnerability for it. Now I got to figure out what I want to do. And this is going to depend on either what you really want to do or what you've been hired to do. Your payload could be that you get on the IVI and you're done. Maybe you're just there to listen on the microphone. Maybe it's a limousine service, and the communication happens in the back of the limo is very important to you. So maybe your game is over there. It could be pulling the contacts off of Bluetooth. When people connect their Bluetooth phone and the contacts get synced, that could be something that you're going for. Communicating with their cell phone. You can manipulate the car components, which is some of the stuff you saw in yesterday's demo. So that's when you're going to be working more on the vehicles network. Typically for my engagements, that's usually what your proof of concept is. You're going to go from as far away as possible to working on the car, actually controlling the car. And so this could be controlling like the steering, it can be unlocking the car, driving the car away, those kinds of things. So if you can walk up to a car, read the VIN off of it, unlock it, and start it, it's usually a pretty good demo. It's not always what you need to go for. Another possibility is reflashing the firmware. Sometimes, if they have over-the-air updates, which a lot of them don't, but if they have these, that's sometimes the trusted source on the network. So they may have some validation, when it's getting the update, over the air, that, okay, I got this piece that I'm going to update with, but maybe I'm going to push it out. So I'm going to push it out to my other hardware components that are inside my car. Sometimes there's no checks between the IVI and the other firmware components. There is technically, these security access codes that you're supposed to put in before you can reflash, but the IVI is trusted, it'll do it for you. So if you're a performance tuner or somebody who wants to reflash, and maybe you don't have the key or you don't want to pay the money for the key, popping an IVI open may give you that access you want. So the car network is a little complex in that there are a bunch of them. So CAN, we talked about yesterday, it's the most common. It's one that I think everybody should probably, if you're getting into this field, start with. That's what the sniffer is that's available for the CTF challenge. The CAN sniffer will get you on the CAN bus, and that controls a lot of things. There are other buses, which you can kind of see on this slide. This is just a demo slide. LIN is a really popular one. It's a very simple bus protocol. It's very cheap. And you can see some of these stuff like around the seat area. You may not be able to talk directly to the LIN. LIN's not usually exposed if you're going to come in, say, underneath the OBD dongle. But that doesn't mean you can't control it. A lot of times, say, for the seat warmer, let's just say. If you were to send a message via CAN, you can send one that says, warm up the seat. It goes underneath the seat itself, and then that converts it to a LIN that actually tells the heating unit to warm up. So just because you're not directly connected, if you bring up some kind of wiring diagram and you're looking, that doesn't mean you can't control it. It just means it's going to eventually go to another protocol, and you may, if you're going to tap into the wire more directly, you may be switching from not CAN to something else. In the screen, you can also see MOST. That's the kind of the red one at the top. That one, you probably don't need to worry about too much. It's pretty much just used for high-fidelity sound and infotainment kind of stuff. Another one you might run into is called FlexRay. It's a little expensive. I wouldn't start there as far as the hacking stuff goes, but it's good to know they're there. It's good to know there's things besides CAN, and you have multiple speeds of CAN bus and that kind of stuff. Again, we're not going to go into all the details of this isn't a one by one on how to hack a car per se. It's going to be the actual exploitation. That's what we're going to focus on. So you can look at the books or anywhere online to kind of see the details of CAN bus itself. So some complications when you're attacking CAN are that if you have a message, and so one of these CAN messages say, we'll just say it does RPM. It's going to come off, let's just say every millisecond. You're just going to get dunk, there's your RPM speed. Dunk, here's your RPM speed. And it's faster than that, of course, but it's just going to come out over and over and over and over and over again. So as an attacker, an easy attack that once you decide you've identified what the RPM speed is, you're going to what they call flooding the bus. You're going to send a bunch of that same message with maybe a higher speed. And so if you can talk faster than the real message is talking, you win. The RPM will go up, whatever will happen. You're still having, one of the complications, you're still having the real system tell it, like, speed of 25. And you're like, 75, 75, 75, 75. Speed is 25, 75, 75, 75, 75. And so the noise ends up looking like the real controller is the noise. So the problem is that because you can't shut that other guy off, you're still going to have that noise. And if the speed of the communication is quick, you have to be quicker. So that can be tough. It's very noisy on the bus. It eats up a lot of the bandwidth to attack it that way. Every make and model is different. So if you find out that, okay, if my goal was to unlock the car door, maybe you have a Honda. And for your 2013 Honda, you know that this particular packet unlocks the car door. Well, that won't necessarily work on any of the GM vehicles, or if you have a BMW, it's not going to work. It's a whole different ID, whole different byte set. With CAN, you don't have a source and destination. You just have this ID. And there's 8 byte packets, so pretty simple. But they're different for every car. That's usually done to kind of give a competing advantage kind of thing, at least in theory. That's arguable. But the thing is that they're different. They sell the information to other people. So if you're really loud on a bus and you have to figure out what it is you're going to attack, you may have to be concerned about IDS systems. Currently, vehicles don't have IDS. They're working on it. They're thinking about it. But let's just assume they're going to eventually be there. What would you have to do to kind of bypass that? And so thinking through this, one of the things I came up with was this tool called Can of Fingers. You can do passive vehicle detection by taking advantage of the fact that because each make and model is different, you can use that to your advantage. So like you have, every car and every year oftentimes have slightly different packets on it. You can then use that information to determine like, oh, well, I'm on this type of car, or I'm this type of car, because it's going to be different. So something that was normally a challenge for getting on and figuring out how a vehicle works, once you know what vehicle you're going to attack, you can use that against it. And the nice thing about this is you just do this by monitoring the wire. So you're not going to generate any kind of traffic. Traditionally, how this is done is you query the main ECU and ask for the VIN number. And then you could do something like what's called VIN decoding, where you basically look at the first couple bytes and figure out like, okay, well, this is a GM, this is whatever. You can eliminate all that. If there was an IDS, they could see that query. Normally, that query is not made normally, especially when driving. Nobody's querying the VIN. The other method is if you happen to be on an IVI, I don't have a slide for this, but if you're on the IVI, you can also kind of look around the IVI system. At the very least, there's usually a splash screen that will say like Honda or something in it. You can pull out data that way, but sometimes you're just not on a full IVI. Sometimes you're on like a telematics unit, which is a smaller module. It's like in a little embedded system, so you can still use Can of Fingers for that. This is a tool you use on the research side. So you wouldn't run this on like after an attack. So you don't get onto a machine and then run this. You run this when you're developing your attack. This is part of you building out your exploit. And so I apologize for being a little hard to read. But COF, the way it works is it'll take that sample set, and you can't see it too well here, but the first several bytes, I'll tell you how it works. There's these IDs at the top, and you'll see like these counts. And so they say like 98, like 978, 978, 978. And there's a drop of how many times it saw those. So I think around 400 and something. And then they drop again. And that's based on their repeating amount on the bus. So how chatty they are. So it takes that in consideration. Most of them are set to certain intervals. So if you take all the ones that are set to be a certain amount of chattiness, you group those to one sides, and we call those common IDs. The other thing we look for is we look at the packet size. That's what's in brackets there. The packet size is up to 8 bytes. On some vehicles, this is always 8 bytes. They do this by padding them out. In this particular example, there's some that you can see that are 2 bytes, some that are 4 bytes. That means there was no padding. We call this one dynamic. If it's static and it's 8, then we also detect what the padding is. Did they pad with zeros? Did they pad with all A's? Did they pad with all F's? All of these things go up to make a fingerprint. And then at the bottom, there's some JSON. That's the output of this how CF normally runs by its default settings. This is the verbose output. We always get this JSON file at the end. In this case, it's saying unknown make, model, trim, because we didn't give it a fingerprint database. And then it's kind of saying the actual fingerprint. So it lists out all the common IDs. It'll give you a main ID that it thinks is the best one to use. And it gives you the main interval. In this case, it's the very bottom number. It's like 00999, 0.00999. So how you use this in an attack. So when you make your shell code, and you want to run on the system to see if you're on the right system, in this case, I would listen for 0.02 milliseconds. If I see 2 of the main IDs during that 0.02 milliseconds, I'm most likely on it. If I don't see it, I bail out. I don't make any network traffic. I stop. I can do additional checks. Because they're all plateaued out at about the same time, even though there's a main ID, during that 0.02 milliseconds, I should have seen the other common IDs as well. And so I can check them off my list. That takes me literally 0.02 milliseconds to do this test. It's very, very quick, and I can immediately tell without creating any traffic what kind of system I'm on. So if I have 2 payloads, so maybe I have a way to unlock a car door on Honda, but I know this radio is also sold on all the GM brands. I can then have basically a case statement. So within 0.02 milliseconds, I can immediately identify what kind of car I'm on and then jump to the appropriate payload. Still without triggering any kind of IDS, at least on the network level. To use the fingerprint database piece, you simply take the JSON file, you add information to it, and then there's a function to kind of add it to your database. In this example code here, it's just giving, this is the one in the test directory. It takes a sample database, fingerprint database of 1 fingerprint. I fed it a log file that says Honda Civic 2007. It's not, it's Honda Civic 2009. It's a hybrid, and there's its information. And it gives you a confidence level. It's about how confident it thinks it is in that match. This one is still just on the research side. You're only going to run this yourself. So to see if your database already has the information, what parts are different. So if you need to know, it's the equivalent of figuring out, I have this exploit that works on this version of Windows. What else does it work on? It's the same kind of thing. So you would do other tests to figure out, okay, what other kind of cars can I make this work on? And you'll make your exploit that way. There's an extra bonus feature you get with Can of Fingers. It's a pattern matching system. It's not very verbose. It's just kind of added, yes, last minute, but it's kind of fun. The pattern part is those B's at the top. There's a lowercase b, capital B, lowercase b, capital B. And those are just bit changes. So this could be off, on, off, on, off, on, or maybe you're doing locks. So that would be unlock, lock, unlock, lock, unlock, 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 lock. It's this pattern that you're going to trigger, and you're going to tell Can of Fingers to look for this pattern. And all this network traffic is floating through your network, and it's a ton of it. And as you do those commands, it will pull it out. So that's what the example is there. If you were to look at the logs, there's a series in this case, just to make it easy to see, the bit changes are between 0 and 1. It can find it anywhere. And it will say, here's your matches. It can find more than one match that would match this pattern you've given it. And it says, okay, it was this ID, position, byte position 6 over. The 2 values I saw it toggling between at a bit state was, in this case, 0 and 1. That could be 26, 27, whatever. This is just there to save you a lot of time. This really has nothing to do with fingerprinting. It's just, since I was already analyzing the data, let's add something else to it. And so when you're trying to figure out things like, okay, well, what unlocks a car? What controls this? If it's a bit toggle that you can control, you can use this to find it in a couple seconds. So it's kind of nice. It's just a little bonus feature. So where do I get it? You can get it from GitHub. If you check github.com/zombiecraig, that's my Git repository. There's a bunch of CAN utilities in there. COF is the Can of Fingers. It's a Ruby package, so if you have Ruby installed, you can do a gem install COF. It'll install the command line tools and also the library. So if you want to incorporate this in some other kind of broader system, this is particularly used on Socket CAN. So you're going to want to use it probably on Linux. I don't know if you can use it anywhere else necessarily for your research stuff, but easy enough to install. The other utility that I wrote is I call it Fleet Management. This was actually written for a reporter for NBC. We have this love-hate relationship with the media. You kind of need them to kind of get your message out there and talk to people, but at least the ones with the cameras really want really sensational stories. And a lot of times they won't talk to me unless I have something demo that's super scary. So I hate doing scary demos, though. I'm just not a FUD person. I want to go out there and talk about fixing problems, not really just scaring the hell out of people. So it's a little tough. Yeah. So I create this tool here. It's a botnet for cars. Is essentially what this is. It's so you can sit there remotely and control multiple cars at once from anywhere in the world. The way it works is, the way you think it would work. You have a car that goes up to a web server and polls for actions. The polling has to be there because the car's network isn't always that great. It can be a little wonky at times, so it does a polling attribute to this web server. It could be anywhere, and then the attacker or whoever's controlling the vehicle sits on the other side and the enters commands. So when the cars connect, they do the thing. It's not that bad. Pretty easy to do. What we're going to do is we're going to watch a little bit of the NBC video. They did a decent job. I don't think they smeared anything too much. We're not going to watch the whole thing. We're going to watch just the demo of how the tool works, and then a little bit from Josh Corman from I Am the Cavalry kind of talk about it, and then I'll stop it.
The Senate study released today shows just how underprepared automakers are to deal with the threat of cyber attacks. And right now, a lot of people are talking about it. But tonight, the I-Team is actually going to do something about it.
Yeah, Chris Glorioso teamed up with a bona fide auto hacker. And wait until you see what he was able to do with a vehicle from thousands of miles away.
Inside this garage on Seattle's south side, auto hacker Craig Smith is tinkering.
So this little piece comes from China. It's about $10 or so.
By plugging a Wi-Fi or cellular dongle under the steering column of this Mazda, he's replicating a potential security risk in thousands of cars, all brands, that have factory-installed wireless communication.
We are using the same signals that would normally be used by the vehicle. We're just now controlling them from the internet.
After deciphering the computer commands that control this car's headlights and wipers, he gave them to me.
Remember, I'm 3,000 miles away here in New York City. The car is in Seattle. This is the command for the lights. I'm sending it. Let's see if the lights on the car turn on.
And the codes work.
Headlights are on. That's amazing. I'm 3,000 miles away. I just turned the lights on in the car, and the switch on the inside of the car is off.
Just to be clear, Craig is not behind the wheel, nor is he behind his computer.
Put him up in the air like, hey, no hands.
I'm the one controlling these lights.
Yep, the lights are just turned on. Nobody's in the car. Craig's outside the car. The lights just turned on.
And I control the wipers, too.
This is for the wipers. Look at that. The wipers are going. I'm 3,000 miles away, and I just turned the wipers on.
Software controls the brakes. It controls your lights. It can deploy your airbag. It can tighten the seatbelt.
Joshua Corman is co-founder of IamTheCavalry.org, a group dedicated to raising awareness about the vulnerable software in lots of technology, including cars.
The one that personally scares me the most is now that there's parking assist features in a lot of these cars, there's a very powerful motor on the steering column. It's more powerful than you are, and it can often be used to rip the steering wheel out of your hands while you're driving.
Mazda sent the I-Team an email stating the company is aware of the growing concerns related to the possibility of vehicle hacking and continually works to improve the security of our vehicles. Okay,
that's enough. I don't even know why they got Mazda involved. This is one of the other things that was part of the rules is that, this is a general thing. I'm not picking on any car companies. That's one of the reasons I used that special dongle. I made sure they recorded me showing me attach a weird-ass dongle to the bottom of the car so somebody could say, like, not really our problem. He modified the car. That was intentional. You don't necessarily have to, as I just explained. You could put this on the IVI system or whatnot. But the point wasn't to pick on Mazda. I kind of wish they wouldn't even bothered Mazda about this. But whatever. It is what it is. It could have been worse. But you will have to deal with that if you decide to start doing demos for people. This is how the software works on the detail level. So whenever you make your relay piece, and so that's the piece that's going to run on your telematics or on your infotainment or on a little dongle. And I can talk about the little dongle later if you want me to. But it just goes out to the website. It issues a polling request where it can pass a VIN or any kind of unique ID. Right now, it's just used to kind of separate the cars from each other. I don't use the VIN decode or anything like that to kind of figure out on the server side what kind of car it is. I just haven't. You could. And then it gives the method supported. So the response, so the first three is pretty much what the original tool did. It had wipers on, off, lights on, off, and flash, and then you could flood RPM, temp, and fuel. Let's just get a demo kind of unit, proof of concept deal. And when we sat down with the reporter, well, sat down, we did it online over the phone. I had him log in and check this out. And he looked at it and he goes, "Oh, yeah, I was expecting something a little harder. This doesn't look really that hackerish, and I think this looks too contrived. Can we make it look a little more hackerish?" I'm like, okay. So I added can send and can send stop. If you're familiar with the Linux can utilities, it's the same syntax for that command. It's not really that command though, because it actually will flood whatever you give it. That's why you have to say can send stop. That was to make it look more hackerish. Anybody else have a problem with saying something looks too contrived, make it exactly the way I said to make it? I kind of thought that was the definition of contrived, but again, reporters. But it is easy enough the reporter can use. We did prove that. So it's web-based. It's Ajax. It's not really a terminal. It looked like he was typing it on a terminal. It's just a website. Uses Ajax to kind of do the terminal emulation of just a simple PHP backend. It has, some of the stuff you'd expect in a terminal, up arrow support. You can hit the Control U and all that good stuff. Does credentials. You can have multiple logins from multiple different people. Currently, you don't really see the other people logged into the system. I don't really use the system, so it's not really that built out. It has some fleet management capabilities and some basic scripting capabilities. You can assign bin numbers to variables. You'll be able to group them, and so you can basically distribute to a bunch of groups. So a bunch of bins that way. It's not done yet for that part. So the grouping of vehicles, it's going to be kind of like an array. That's kind of how it's going to work, which you can also then save. That's the other piece I want to add too is when you're saving it, I want to save it to a backend server-side state. Right now, once you log out, it kind of clears it. It's just that session-oriented thing. But I think I'm going to save on the server side. The other thing I was going to add is some geolocation stuff. So if it has the capability as a feature to say like the location of the vehicle, that would be kind of really cool to have. And also the DTCs, that's the diagnostic trouble codes. That's your engine light and kind of problems with. You can basically make OnStar with this, which would be kind of fun in a scary kind of way. So I haven't released this yet, and I've been debating about it. I don't think I'm going to. I mean, I kind of told you enough to build it yourself. I mean, if you really have a really good reason to get this code, I mean, you have to be really convincing. You can contact me. We can work on something. It's mainly because there isn't a real solution for this yet. So I don't really know what I'd be getting out of this by releasing this tool. It's not pressuring anybody to do anything, to fix anything. It's really just for a demo. And even this demo, I never did again. I did it once, and that was it. So I mean, if you really want to contact me, I'm probably not going to release the source code to this. So what can be done? I mean, unfortunately, there's not a whole lot that can be done as individual users. We still kind of really have to rely on the auto manufacturers to do a lot of this stuff. I let the Josh Corman do his I Am the Cavalry little speech there, and it's because I really support I Am the Cavalry. It's a great group. It's just a bunch of security people who get together, if you haven't heard of them, to kind of work with some industries. A lot of times it's Internet of Things kind of people to kind of do lessons learned from stuff we already know, from cell phone manufacturing and server-side stuff, just as opposed to reinventing the wheel and redoing the same problems we saw before. Let's do lessons learned and just jump to the end. That'd be fantastic. They came out last year with this 5-star cyber safety program. It was targeted towards automotive, but it really kind of applies to any Internet of Things. So it's like safety by design, evidence capture, all that good stuff. And I had a post once where it was, if you're releasing any kind of Internet of Things device and you can't do these 5 points, you're not production ready. Plain and simple. You can't update it over the air. You can't tell if it's been modified. I mean, these are honestly common sense things in my opinion. We wouldn't attach something to the internet like a web server without having these things. So why are we attaching any other device? The plain speak over there is just if we were talking to somebody else. These are just failure controls. I mean, cars kind of deal with failures. That's kind of how their safety standards are. So it's piece fails, whatever. So the plain speak was just an aside for that, to kind of make it a little easier to understand. So if you want to get involved with, some of the car hacking stuff publicly and openly, or with any kind of group, I Am the Cavalry needs more than just auto hackers. Anybody who's interested in this stuff, you could be doing PR, whatever it is, feel free to reach out to either of these sites. I'm the founder of Open Garages, so it pretty much goes to me. Open Garage is also where you can get the book at. There's a Twitter handles for the two. Also feel free to tweet at ShakaCon. The book, that's on the website. It's the 2014 Car Hackers Manual. It's a little light on information, in my opinion, and that's because the story behind it was that this book was written to go along with a class at the USCC. It's the United States Cyber Challenge class, and so it was their training manual. But it went with a whole day talk on how to hack cars. So if you ever get this book, you're like, oh, it seems like it's missing some details. It's because it was in the other part. I released it open source for free. It ended up shutting down my ISP. There was so much demand for it. We had 300,000 downloads in the first 4 days. And it was from all over the world. And my ISP shut me down. And that's when I realized that people want to do this, or they're at least really interested in it. I had no idea of the interest until that book kind of came out. So I started over, made it another one that is technically done as far as the writing part is since the beginning of the year. But No Structure Press is going to handle this one. The first one was self-published. No Structure Press is going to handle it. It's a lot bigger. It's over 300 pages or something. But it'll step you through all of these little pieces. This is like basically the chapter layout for the new one. We can go like side channel attacks, step by step, how to do shell code, all that good stuff. It will still be free. So it'll still be a free book. That's part of the negotiations. I don't know when it'll be out. I was hoping it'd be out for ShakaCon. That was my goal. Not ready yet. I might have some samples out for DEF CON, maybe. We'll see. So originally, this is my questions time period slide. But I want to kind of do a little rant piece and also kind of give you information. It's more of like a challenge. The way auto manufacturers, for the most part, work right now is when they're working on vehicles, the stuff they're working on, the new stuff, isn't going to be out for another 5 years. Their cars are done up to 2020. They've already designed them. They're not making modifications to them. They're done. So as a security researcher, that obviously is rather frustrating to think that, oh, if I were to tell them something, at best, we'll fix it by 2020, at best. And that's the current state of things. And so it's something you have to be aware of. And because of that kind of stuff, and because the old traditional way of being non-connected, and that was fine to do a 5-year turnaround at the time, they're not always friendly to you. So it's still at the stage, it helps to know how to get information to them. So if you start doing this research and you start finding vulnerabilities and you become maybe worried about them or concerned, everybody here, I'm sure, is only going to do this research because they want to see if their car is safe, and if they find something, they want it fixed. I mean, that's almost always our issue. We just want things fixed. So right now, I would say go to I Am the Cavalry. You can go to Open Garages too. If you find something, let us put you in touch with the security teams at these other organizations. The security teams typically get it. And they typically know how to take this information and kind of walk it through the right people so they don't immediately send their lawyers after you. If you send it to their help desk, it'll most likely go right to the lawyers. But if you go through the security team, it'll help. We're working on getting several OEMs, which is the auto manufacturers, to have responsible disclosure policies. So at the very least, you'll have an email you can send to. That would be great. Don't expect a 90-day turnaround time, like from Project Zero yet. It would be, I don't think you shouldn't demand a 90-day turnaround period, but it's just they won't have one yet. Down the road, I think they absolutely should. I think anything on the internet should. But they're not quite there yet, just so you know. I think that is a good goal for them to get there, but they're not there yet. I would say within the last year is when they really start to take security seriously in the car, from like what I've seen. There's been plenty of research on this where we've done demos wirelessly before on cars for like, at least what I've been involved in the last 4 years. But that's in the last year is like when they really start to have security teams. But unfortunately, they're doing the same thing that we always, this is the rant part, that we always do when we're starting out, is they're taking this closed source group, they're attaching it to the internet, they're like, oh, now we need security. Let's move a bunch of people from other departments, and then now you're a security team. And then what do you do when you're in that situation? I mean, you're this one department at one time, now you're the security team. You do have active people looking for vulnerabilities in your vehicle. You panic. That's what you do. And you want to go buy something. You know, that's what they do now in the financial industry, wherever. It's like, let's buy the latest whiz-bang thing to help me do my job because I'm a little overwhelmed. The problem is there isn't a whole lot of things to buy but there's a lot of companies scrambling to fulfill that need. And I would say they're rather half-baked at best, a lot of the solutions, because big companies are seeing money. They're seeing money signs, and people are willing to throw money at the problem. And unfortunately, I think they're going to probably roll out the same things we've already seen. They're going to do like firewalls, IDS systems. It's probably not a good solution if in a talk in 2015, I can tell you how to bypass those. So in 2020, they're already broken. So I think we need a little more work, kind of do lessons learned. This is getting towards the end of my rant, where we actually hire real security people who can do real testing. You might have to re-architect some of this stuff. Most of the segregation that's in there is based on speed. This bus got busy, so we made another bus. They're not based on the functionality, not based on security. The parts that connect them, just route them. They're not really, you can put firewalls in. I'm not saying don't ever do a firewall, don't ever do intrusion detection. Just that's nowhere near the silver bullet you need. That's just a piece, just like you have on your regular network. I mean, we have firewalls today, and it's just there. It's like our keynote said. It's it's a firewall, but it doesn't really do much. So same thing will happen with cars. It's not going to do much. The only firewalls I've really seen so far have been on the OBD dongle part. So you can block some pieces there. And it's just not enough stuff. I think you can do a lot more stuff using your sensors. You have a lot of sensors. My personal opinion is the security probably needs to be looked at more as we do our human stuff. So I have 5 senses, and it's easy to trick one of my senses. But it's hard to trick all 5 of mine. But that's really what you have to do to really fool me, to fool my brain, is to trick all 5 of my senses. Cars have a lot of sensors. Right now, you have to fool 1 at best. The rest are pretty easy. You can just take them over. But instead of doing IDS, use your other sensors to make intelligent decisions of what you're seeing. All right, so now, hearing that stuff, and kind of having a gist of how the industry works, seeing some of the newer kind of tools that can be used in exploitation, I'll take any kind of questions you guys have. You talking about the rate limiters? Yeah, so the questions about performance tuning and eliminating rate limiters. I personally don't do the performance tuning side of Open Garages. So Open Garages is a community that anybody can join. I started initially thinking there'd be a bunch of security people getting together to hack cars. And what I learned from the day one of our first meeting we had was I was the only security guy that showed up. We had a bunch of mechanics show up, a bunch of performance tuners show up. We had art people show up who wanted to do some Burning Man stuff. And I was like, wow, there's a way bigger need for like the types of information that we're digging into. So I couldn't personally tell you exactly what I do with that, but we definitely do it. It's typically done at the firmware level, is my understanding, with the ECU. But again, I don't do that piece, especially the rate limiter. But they're usually parameter changes. And so sometimes you need a password to do that. And I do that part. I help with the password to get to the ECU, but then I don't do the parameter changes.
The other thing is, back in the 60s, we had Ralph Nader and the whole safety automobile thing. Do you see something like what you're doing as far as the safety risk being presented to an advocacy?
So the question is like basically doing like a safety standard for security. There's actually talk about that right now. I didn't let the video play all the way through, but there's a senator that comes on right after that who had a proposal, and it wasn't a bad proposal. It just doesn't have any teeth, I guess you would say. So like one of the things in it is like, vehicles need to have a third-party security audit. It's a valid statement, true, but like who's checking it? What are they checking for? Some guy always does web apps, and he looks at the car and goes, looks good. I mean, that don't mean anything. Don't give me a stamp for that, So we have to have that list. And as a security group in general, we don't have that. We don't have the same classifications for vehicles that we have with web. You can't sit there and say, oh, this is SQL injection. It's this level risk. For instance, just say if I wanted to say the classification of gain entry to a car. Can you gain inside a car? It's this level risk. Now, like if you were to tell me what the exploit was, I can tell you how bad I feel it is. Like, oh, from wirelessly, I unlock the car doors to go steal something. Okay, it's here. Or maybe I use an amplifier on the car, and I can get you to unlock the car from sitting in your house. Well, maybe it's a little bit lower. Oh, I threw a brick through the windshield. Okay, technically you did it, but I just don't give a crap. And so like like bug bounty programs have that problem too. So if you're going to classify it, like you usually say like, oh, for these types of attacks, we'll give you $200 or we'll give you $400. For the car, we're still at the stage like, well, I know as a security guy, I just haven't been able to put it into the right words and give it a nice little label that people can kind of classify their stuff at. I think maybe once we kind of work that out, which will probably be soon, we might be able to move a little forward on doing safety rating type stuff for this. I mean, there's safety standards for sure. The ISO 26262 has this thing called an ASIL standard, ASIL, but it's really based on a part failing. So like a part just, if this part fails at 60 miles per hour, how bad is it? Basically, how many people are going to die, and if enough die, well, we'll do a recall. It's kind of how that works. Yeah. I mean, if just a few people die, it's fine. And so the change will have to be like, one is that it's not just a part failing; it's the part's still working. It's just working maliciously. The whole concept of pivoting, that kind of stuff, doesn't come into ISO 26262. They're starting to look at addressing that now. So all the safety doesn't really deal with that. And if you have over-the-air updates, we don't really have to do this long-term recall. Recall has bad stigma in it anyway. So this way, if you were to find a vulnerability and report it, maybe we can shoot for more of that 90-day thing where people don't have to die first. I just tell you there's a problem. You go, yeah, it seems legit, and you fix it. There's some complications for fixing it. I mean, you have to do at least the same kind of encryption you do on a phone update, but you also have to do a couple other things you wouldn't normally have to do. Like you wouldn't have to do an update, or you wouldn't want to do an update while somebody's driving. You don't necessarily want to make it either, too. When they go to turn on the car to go to work, oh, please wait for an hour while we update all your signatures and stuff. That would suck. So there's some things you have to do to make it right. But they're easily to overcome. We've done it before in other areas, and we have to do it again on cars. So I think once we kind of have those in place, that'll be a little bit better. And then I think we'll get to better safety standards and get some more teeth on it.
It's not hard to take the technology that you're talking about now and just, my next door neighbors, two of them are Airbus pilots, and they call them the flying laptops. I don't see that there's any major security in there either. I mean, it's pretty scary to think about airplanes being, they're all internet connected now.
Right. Well, and that's what the 5-star thing. It almost can be applied to anything that's connected to the internet, be it a plane, be it a medical device, be it whatever. I mean, if you can't do those 5 things, you're not production ready.
Some airplanes might just disappear without explanation.
I'm not going to make any speculations of airplanes disappearing before I disappear. I think I'll leave that off the table. But yeah, I've heard the same joke made with cars. Some people said, I can't remember who it was, but he said, why did they put wheels on vehicles? And it's to keep the computer from scraping the ground. And it's fairly accurate. I mean, they're basically just network on wheels. That's what they are.
Can I get a firewall for my car?
You can't really as an individual right now. And if you did, where would you put it? So like, for instance, if we go back to the picture of the network stuff, let's see if I can find that real quick. Sometimes there's choke points, and maybe you could put it at a choke point. It depends what you're trying to protect. Where's it at? Here it is. But these are buses. So the way a bus works, it works like a hub. So everybody sees everybody else's packets if you're on that same busless segment. So that makes it difficult. And the reason why CAN is this way is because it really has to be very fast, very efficient to give you information. So you want to basically say, hey, I'm braking, and you want that information to be there right away. And so it has a lot of safety in the form of eliminating noise that you would normally see in a CAN packet, but not so much in the form of somebody lying and say, oh, you need a brake, when it wasn't the brake controller saying something like that. So if you're going to put a firewall in here, like maybe you put it down where somebody plugs in to prevent like valet attacks, or to make sure that the progressive dongle that you plugged in doesn't get hacked, or something like that. I mean, it could save a certain risk segment. That's what I'm saying. Firewalls aren't necessarily bad. It's a knee-jerk reaction that doesn't really solve a greater problem. Encryption's another one I hear a lot. Like, well, let's just encrypt CAN bus. Doesn't really help you. You're now going to have a much larger amount of packets being sent to say you're braking, and there's nothing secret about that packet. I mean, yes, I can figure out what breaks. What this byte unlocks my car door. And yes, I use that for payloads. But personally, as somebody who likes to tinker, I'd rather, when I bought my car, just you give me that information. I mean, in my mind, it's my car. I'd love to know how my car works without having to do this step. I'd love to have the wiring diagrams included in my owner's manual. That shouldn't be a subscription thing. I don't like those things. I'd like to see those things fixed. I have no idea if they ever will be. But there's movement to get some of that stuff fixed. I was involved with the Copyright Office recently, arguing for Class 21 and Class 22 of the DMCA exemptions. which will, if they go through, it will kind of give you at least more leniency to be able to talk about things and share stuff. Right now, it's really questionable. If I were to document like all the packets in a certain vehicle, those are sometimes sold for around 25 grand. And if I were to take that one file and publish it, that I created on my own by doing reverse engineering, will they come after me? Nobody's tried it yet. GM has said they would. They would come after you if you did something like that. So, I mean, I believe them. But I don't think I shouldn't be able to do it. I don't think that's knowledge that people shouldn't have. So I think we're coming to head, and everybody needs it. There's this generic diagnostic kind of piece, like that's supposed to appease this. That's the OBD connectors. That's a standard connector. So you can do standard diagnostics, but they're read-only. You know, it's a read-only kind of thing, like, oh, what's my current speed, or you know, how are things looking? But if you want to do something complex, like say you have a pickup truck, and you need to carry more weight, you want to change out that axle on it. Well, you have to change the firmware on the vehicle so that you can deal with the new rotations, or else your speedometer is going to be off, your shifting is going to be off. That's not a read-only operation. In order to do that stuff, you have to have the same low-level access. So it's coming ahead, I think. Hopefully those exemptions will go through, and maybe we can go a little further on the tinkering part and the open communication piece. We're used to that in the software community, just having open communication. We can just say things, and you know, academia isn't attacked. It's not horrible in vehicle, but it's not great either. They still will attack you. They're still not totally cool with working with just people on the street. You know, in their mind, they think, well, you know, we've done all the safety testing. We know what we're doing. You shouldn't touch it. Actually, GM went a little bit farther and said that in their case, like, they took the claim that software is copyrightable. All the pieces and all these chips in the vehicles run on software. There's an implicit copyright. GM owns your car. You don't own your car. They decided to go ahead and make that statement. In the Copyright Office, they did that. So there'll definitely be a fight at who owns the car. Because I think for most people, that's news to them, that they paid $30,000 plus and they don't own that car. So hopefully we'll win that fight. We'll see.
Do you know a way how you can disable the Wi-Fi modem on these cars that are connected all the time to the Wi-Fi? Just so that someone doesn't want to turn their screen while you're driving.
So the question is there a way to disable the Wi-Fi and the modems and that kind of stuff? There isn't an official way usually to do that. I mean, obviously you can cut the wires, and that's what I recommend. That'd be fantastic. I mean, I think they should offer it. Matter of fact, if you disconnect or remove your, I hate to pick on people, but if you remove, but sorry, I picked on GM, it's fine. If you remove the OnStar, they'll call you, even if you're not paying for that service. They'll call you right away and say, oh, we're detecting a problem with your car. Bring it in for a free service check, because they want the OnStar. They're using it. So even if you're not paying for it, they want it in there. So right now, they're definitely not an on-off switch for it. It would be nice to have. I agree.
A Wi-Fi jammer in your pocket, just like
Don't think Wi-Fi jamming while driving is legal, but
yeah,
I'm not. That was the end of my sentence, actually. I didn't have anything else to add. It's just I don't think it's legal. Functional, yes. Any other questions? Oh, yeah.
For car software updates, how often have you seen them, and when have you seen them like really update?
So that's changing. Actually, my first car hack that I did, and we'll call it a car hack, it was for an infotainment center, and that was that one that had the Hitachi processor. Their update was on their DVDs, and so if you were to buy a mapping DVD for $250, they had the ability to put extra software on it. And that's actually how I got in. I saw these DLLs and stuff, and that's where I made my modifications. I changed my splash screen and a bunch of other things. I was actually shooting to get music videos playing on my infotainment. That was my goal. But that's how they used to work, and honestly, they didn't usually update the OS. I mean, it had to be pretty major to be on it. I think as they get to more over-the-air, and it's not that big of a deal, you'll see more of it. BMW recently did one where there was a vulnerability found with the over-the-air update, which included not using encryption. But they did a good job, and that it was brought up to them by a third-party researcher who said it, and they had fixed, I think within the 90 days, if I remember right. And they pushed the update down, they fixed the encryption piece, and that's what I want to see. I mean, that's fantastic. So some people, I think, when the news stories came out, of course, it's the news, and they're like, BMW hacked, but honestly, they handled it right. It's a vulnerability that's going to happen. We're going to find vulnerabilities. I mean, there's no way, you can't make it not there. Like, even if you do everything right, you have encryption and all that stuff. I mean, you get Heartbleed or something. You're going to have to be able to update it. And people aren't going to want to take off work every day to drive in to get their daily updates to a dealership. So in my mind, there's no other way. Even though you do add attack surfaces to have a remote update, the reward's better than the risk in that one. So I hope to see it more. Right now, I'd say you don't. You're just not really seeing them. Where's the question? Oh, there you are. Sorry. Thanks. Will OEMs break out the 5-year turnaround? I hope so. Tesla doesn't have it, but Tesla isn't in the same kind of development cycle to begin with. So they started different, which is kind of cool. I guess it's one of the, you can be kind of like that when you're like a startup kind of, I guess, or a startup kind of thing. But it will be tough. I mean, that's a huge mindset that they have to change. They're a machine, and it's not just the security department, obviously, running, making business decisions. And that's the way things have worked forever for them. And it's mainly because it was physical. These were closed networks. These weren't attached to the internet. You didn't have to worry about them. But the game changed when they attached them. And they attached them in ways they didn't realize. I mean, the phone home systems have an IP on it. When you press that little button, like, oh, you heard you got in a collision, we're going to lock your cars. That's an IP. It's a PPP link at least. Your Wi-Fi obviously has it. There's obviously wireless ways of getting into these systems, which puts them now in the same game as the servers, as the cell phones. And you really do need the same turnaround times. So at least those aspects, the software aspects, have to be shorter. They just have to be. I don't know if they'll ever do it for design perspective about 5 years. That'll be a huge change. Any other questions? Very good. Okay, well, thank you for your time. Play the CTF, get a can sniffer, and hack your cars.